And welcome, Kevin and Sai. Welcome to class. Again, if you want to unmute your mics and test them out, you're welcome to do so. We'll start up here in just a minute. Hey, Trevor and Prashant, welcome to class. Welcome to the workshop. We'll get started here in a minute. There we go.
Yeah, sure.
Prashant, is there a question? See, you've got your mic open.
No.
Okay. Fair enough. Thank you. So again, folks, welcome to the session. We'll start up here in a minute or so,
All right. Hi, everyone. Good morning. I hope this is a wonderful Thursday for you. My name is Dilip Rajan. I will be co-presenting with John. So thanks a lot for joining this webinar workshop. We want to talk to you about AWS services and how Sumo Logic and AWS work together. But before that, I'll give you an introduction about myself. My name is Dilip Rajan. I'm a senior partner architect at Amazon Web Services. I've been working with Sumo for about 2 years now, and I work very closely to build integrations with Sumo. So hopefully in this webinar, we'll talk to you a little bit about some of the core AWS services, and then hand it over to John to talk about observability from a Sumo Logic perspective. John, do you want to quickly do your introduction, or we can get started?
Sure. Just give me a second. Hi. Hey, folks. Good morning from the East Coast of the U.S. My name is John Meredith. I am a technical trainer here at Sumo Logic. Have been with Sumo Logic a little less than 3 years. Also have a couple of AWS certifications, so played in that space. Also worked as a DBA, a programmer, network admin, all that fun stuff, an IT manager. But enjoy doing what I do best, which is teaching. So that's why I'm here. Want to welcome you all to the session. And as a trainer, the only thing I'm going to ask is if you've got questions, please let Dilip or myself know. Ask your questions, please. Thank you.
Okay, thank you so much, John. All right, so let's get started. First, I've done my introduction, so I'm going to take you through an AWS service called Lambda. I think there might be a variety of folks here in the audience, so I would love to sort of get a question going. How many of you all folks are familiar with AWS Lambda? If you could just type it out in the chat box, that would be useful to get a sense of how deep I should go in this conversation. All right, so I think we're a little okay. I am all right. So there are folks. Okay, good. So I think we have a sort of mix of folks. I will try to sort of make sure that the conversation and the presentation is attuned to a variety of folks. So there will be some fundamentals that I'll go through, which might be familiar for a variety of folks, but at the same time, it'll also set the context for the rest of the conversation. So really the goal here is to talk about how Sumo Logic enables observability on Amazon Lambda. So for that purpose, it's good to sort of set the context from a fundamentals perspective, some of the controls, the optimizations, and then the enhancements that have taken place in the last couple of years that allow for better observability from an AWS Lambda perspective and a Sumo Logic perspective. So hopefully this agenda will cover a gamut of those concepts. But just to set the context, I want to take you through some fundamentals of Lambda, right? Just in terms of serverless applications, a function is nothing but a resource that you can invoke from your code that executes in Lambda. It is a event-based activity. So for a function code to execute, the code needs to process a certain amount of event that has come because of a certain reason, right? It could be a change in data, it could be a change in state, or it could be an actual request that comes from an HTTP post or an HTTP GET request to an endpoint. So once that request is created in a JSON formatted document, that contains the data for the AWS Lambda function to possess and execute. And that would further trigger other activities that take place within a serverless application. So in a nutshell, a serverless application is nothing but a code that can run in a variety of runtimes. And as far as the AWS Lambda is concerned, it contains a variety of runtimes. You can even have your own custom runtime that Lambda supports. And essentially, it's a trigger-based event that allows you to process events in a nutshell, right? Okay, let's take a little bit about a different view of what AWS provides from a operational responsibility model perspective. And at the bottom of the stack, of course, you have the Amazon EC2 instances where you do everything. All AWS provides you is only the physical hardware and the networking and facilities, but everything else from security, from application core, from patching, everything is the responsibility of the customer or the developer, right? As you go further up the stack, there is some availability from a management perspective for ECS and EKS, which is container services and Kubernetes services. Of course, if you take a higher layer than that, which is Fargate, it is more of an automated way. But really, Lambda is that layer of computational responsibility, which is a more opinionated approach where all you have to do is manage the application code as a customer, and AWS manages every other aspect of Lambda, of your compute layer, right? Let's talk a little bit about the cost, and we'll talk about the execution models, and then we'll move on to the advanced concepts, which is what I think most of the folks might be interested here. In terms of cost, one of the really cool things that came out in last few years, ever since Lambda came out in 2017, was that you can have precise cost measurements up to 1 millisecond billing. You only pay for what you use, and you don't need to pay for any patching and maintenance. So really, that in a sense, when the cloud was first created, we all talked about pay for what you use, but in a sense, you still had to sort of wait for execution, wait for compute, wait for resources. There were other factors to it, but really, Lambda is the one that's really designed for pay-per-use capabilities, and that's really where the end game in terms of cloud is going to be. Okay, so now we've done cost. Let's go into execution models. Why this is relevant? Execution models give us a clear idea about various ways in which Lambda functions can be used. I'm going to go through this rather quickly, but at the same time, I'll try to make sure that you're getting a flavor of how Lambda can be used in various scenarios from a modeling perspective, right? So first is a synchronous push model where you have a quick response that needs to be provided to a business request, a HTTP get a put request, and something that comes from an API gateway, and that Lambda function is required to provide the response quickly. The second model, which is also slightly different from the synchronous model, is the asynchronous model, where the Lambda function code is going into an Amazon S3 bucket or an Amazon SNS topic and retrieving certain pieces of information, performing a logic, and then providing the result back. You don't have to have a high latency response on this. So the model expects you to be able to perform a slow response, which is okay. And that's what's called as an asynchronous event-based model. And the last, which is probably more where Lambda is going into, which is the pool-based or a stream-based model where you might have an Amazon DynamoDB stream, which contains a stream of data, or a Kinesis streams. Again, it consists of various, within a particular shard, you might have a lot of data messages that are coming in. And that what the Lambda architectural code does is it goes and retrieves a certain pieces of those messages and then executes that in the business logic of whatever that you need the application to do. The stream and the pool-based execution model is also rather popular when it comes to making sure that the Lambda code responds to various facets within an application service, like DynamoDB or through Amazon Kinesis. The important portion we talked about in the first slide was event-based sources. So it's important to sort of also understand about other services, not just data stores like DynamoDB and Kinesis, but also other endpoint services such as an IoT service or step functions, which is available in AWS or even the configuration repositories. So really, the really core benefit of Lambda is the fact that it has 140 plus integrations across all of AWS services, and we continue to add more capabilities along the way. Okay, great. So hopefully in this last few minutes, I've been able to give you a decent sort of flavor of what Lambda does, but let's take a little bit deeper dive into some of the advanced concepts of AWS Lambda. And then I'm going to tie it off to Sumo Logic before I hand it over to John. So the first thing to talk about is concurrency and scaling. So let's talk about concurrency. What is concurrency? Why is it required? And why is it relevant from an AWS Lambda perspective? Really, in a nutshell, concurrency is the total number of requests that your function is serving at any given point of time. So when your function is invoked, that time a Lambda allocates a certain instance for that function to process that event, right? Once that, if another invocation takes place, then Lambda will allocate another instance. So your concurrency is increased to 2. That is essentially, in a nutshell, what concurrency means, right? The total number of instances that you're having for concurrent applications to execute. There are 2 knobs that you have, but it's called reserved concurrency and provision concurrency. So it certainly helps to understand why you need to control those knobs, because concurrency is controlled at a regional level at Amazon. So it's important to make sure that you're controlling that way your application doesn't get throttled for no reason, right? So let's talk a little bit about the fundamentals of what concurrency are. And this slide may be easy to understand, maybe harder, but it's good to have the context of this so that when you go back to your Lambda, you can kind of really understand how the levers are moving. So if you have a TPS of 100 with a duration of 500 milliseconds per execution, then your concurrency is going to be 50. But if you have the same TPS, or the throughputs per second, but you're having a higher duration, then that would mean your concurrency is close to about 200 at this point. So there's the ultimate deciding factor could be either throughput per second, or it could be the total number of, it could be execution time per function that determines the total concurrency. So that's really a good flavor for you to understand. I want to dive into the next slide, which is how do you control the concurrency of your application so that your application doesn't get unnecessarily throttled. There are some cost controls in place, or there are some methods for your application to respond better to events. So let's take an application, for example, a mobile application that is processing a large number of events. So in that case, you want to make sure that there is a certain number of pre-warmed instances that are available within Lambda that allow for those events to respond. For that, what you want to do is you want to set up a floor, and that floor is what's called as a provisioned concurrency. Right? It's nothing but a pre-warm set of capabilities that are available to process the event, and it can also sort of help you with cost savings over a period of time. And that's the total objective of having a provisioned concurrency. And similarly, if you're having a floor, then you might say, hey, do I have a ceiling? And that's where we might come up and say that we have a capability called as reserved concurrency, which guarantees a maximum number of concurrent instances that are available for a function to execute. So when a function has reserved concurrency, no other function can use that concurrency. It obviously is available within the account's quota, and there are no charges that a customer has to pay in order for configuring that reserved concurrency for that function. And one of the key benefits that I've seen in real life is the fact that when you set up a reserved concurrency that sets the ceiling, unwanted cost overruns do not take place. It could potentially throttle the number of the response time for your application, but some customers are okay with that because sometimes cost overruns from unwanted Lambda spikes can occur, or you can also have the other problem where because you have a regional quota, unwanted throttling is taking place. So this sort of helps you with timing your application, making sure that unwanted throttling doesn't take place for no reason. So both, I think, provision concurrency and reserve concurrency help you manage your application responses time from a Lambda perspective. Great. Let's talk a little bit about optimizations. This is where it gets interesting because we initially, when Lambda was created, it was like, let's have a code that can run anytime. That was the core concept. But then customers started saying, what about containers? What about consuming logs and metrics? So that's when really we started thinking about how do we design an application where various open container images formats can also be used. So the first concept that we need to understand for optimizations is Lambda layers. And so Lambda layers is a simplified way of using your functions so that it can share code across various Lambda functions, right? That's what it is. So with layers, what really happens is developers can upload code once, and then they can use it multiple times. It has got built-in support that it can allow for the code to be shared across ecosystem. And this promotes sort of separation of responsibility. So certain developers can focus on managing the core library capabilities, and other developers can focus on building application logic on top of the library code. The other benefit that comes out of using Lambda layers is that it allows you to package your dependencies instead of having to duplicate code across various functions across your Lambda application. So for example, if you think about it from a thin wrapper perspective, customers often have these patterns of thin wrappers in their core functionality, and layers makes it easy for customers to reuse that code within Lambda. The core innovation that goes into Lambda layers is really how it gets initialized and loaded. And we have done some foundational work to ensure that Lambda layers is executed in the right way for various extensions, various logs, and those capabilities to be included as a part of Lambda layers as well. So with Lambda layers, let's talk a little bit about what are the limits of Lambda layers, because sometimes it's good to talk about what are the confines of what you're working on. So in terms of Lambda layers, you can have up to 5 layers that are attached to a function. You can certainly upload the code that you're having into a zip file. You can use versioning. There is a certain sequence that needs to be followed when, so order certainly matters. And an uncompressed size of a Lambda layer could certainly process about 250 megabytes. So various programming languages can be used within a particular Lambda function with multiple Lambda layers. Okay, so hopefully I'm able to now be able to connect you with from Lambda layers to container images. And in the next slide, I'm going to talk about container images. From container images, I'm going to go into the execution environment. So all of these are interconnected in a way when all of this will fit when I talk to you about the execution environment, because really I'm setting up the foundation for all the pieces that are there within Lambda. And then finally, the execution environment will sort of tie everything together for you. So bear with me for a couple of more slides and it will help sort of set the context in the next slide. All right, so let's talk a little bit about container images, right? It's useful to sort of talk about the history also, right? Customers basically asked us, look, I want to standardize on the basis of on consistent operational tooling. We also know that containers, container tooling and packaging needed some standardization. So the team came up with a thinking that we need to have a set of tooling and training for all of the software lifecycle capabilities, for example, building, testing, and packaging. And that's why we wanted to launch this capability of supporting container images. The goal here was very simple, to make sure that the investment in container tooling is available within Lambda. And at the same time, we are also providing the customers the full benefit of having integrations of Lambda across the 140 plus AWS services. In addition to that, the other benefit that we thought about in terms of Lambda was that if you have a cold start container orchestration problem that exists in other platforms, Lambda would help you solve that because it'll be much faster in terms of automation scaling. So for those two reasons, we think that Lambda with a full container support is a great option for customers. So as a part of that initiative, we wanted to sort of support in launching containers within Lambda. So it's not just about sort of simply adding container support, but we've also added additional capabilities such as being able to have a larger package size, meaning larger container images for example, machine learning models that could be also included as a part of Lambda. We've open sourced all the supported language runtimes so that you're welcome to start your own base image. And then of course, we also have the ability to use the Lambda runtime client events along with Lambda runtime emulators so that you can use it for local testing, for example, in a Docker desktop. Right. So these are the core benefits of using Lambda from a container image perspective. Now comes the fun part, which is Lambda execution environment. So this is going to really talk about how all of the other topics that we've talked about sort of put things together in perspective. First, let's take a look at the execution runtime environment, right? So when a Lambda invokes your function, it invokes that function in an execution environment. This execution environment provides a secure and isolated environment. And in addition to that, the execution environment also allows you to manage the resources within your function, right? So as from a lifecycle support perspective, we want to make sure that the execution environment has all of the runtime and external dependencies associated with that function. So, so this will sort of make sense in the next couple of topics that I'm going to have. The function runtime communicates with various endpoints, right? For example, your extensions API, your runtime API, and the logs API. So just as an example, logs API would mean that you are going to be able to receive your messages from your function by subscribing to the logs API. So it adds an additional layer of comfort when you're having to execute the Lambda function without having to sort of bother about loading all of those code variables within your Lambda function. Sort of provides that separation of responsibilities, if you will, for a Lambda service within the execution environment. Right. So next slide, I'm going to talk to you about the process of execution. So we've talked about the extension API, the runtime API. So let's talk about that in an execution environment perspective. Right? The lifecycle environment for a Lambda function has three main phases: the init, the invoke, and the shutdown phase. In the init phase, the Lambda creates or unfreezes an execution environment with all the configured resources. It downloads the code, the function, and all the layers that we talked about, Lambda layers before. It initializes the extension that we talked about in the previous slide. And then it takes the functional code outside the main handler. So if you think about the Lambda function, it has it has the main handler and the code is there. All of that code within the function is left aside, but everything around it is taken and initialized in this first phase. The initialized phase happens in the first invocation, and in the advanced invocations, you can have concurrency capabilities as well. So if you have a provision concurrency or reserve concurrency, And the init phase happens during the first invocation, and the advanced functions will happen at a subsequent layer. There are sort of the first diagram also shows you the subphases of a Lambda execution environment. That includes the extension init, the runtime init, and the function init. These three subphases ensure that all of the extension and runtime are complete before the function code runs. So obviously, as you can imagine, we don't want to we want the code to sort of run in an environment where all the dependencies and all the extensions are already in place. But that's really what it does. This next phase is the invoke phase. And in the invoke phase, the Lambda code is invoked within the functional handler, right? After that code is completed, Lambda prepares to handle another invocation. So this continuously happens. So obviously the init happens once and the invocation can happen multiple times. This allows for like the pre-warmed environment to be available whenever other invocations are executed for your application. Once these invocations is done, we can talk about the shutdown phase. And in the shutdown phase, if the Lambda function does not receive any invocations for a particular period of time, the shutdown execution starts, and it initializes an alert to the extensions so that they can stop cleanly, and then starts removing the environment. The shutdown event is sent to each extension that the environment is about to be shut down, and your application starts to slow down. So really, hopefully this slide gives you a clear picture of the fact that we have various layers. Those layers of extensions, and those extensions are the ones that are extensions and various init capabilities, and that sort of ties this back, all of this presentation into one Lambda execution environment. Now, let's talk a little bit about how these things are relevant from a Sumo Logic perspective, right? Okay, so one of the core benefits of using Sumo Logic is that Sumo Logic has natively integrated with Lambda extensions API. So if there is a lifecycle event that takes place within a Lambda function, you can initiate a response to that lifecycle event. Those responses and the lifecycle events can be integrated with any of your observability, security, and governance tools, including Sumo Logic, right? So function authors can use extensions to ensure that the right extension API is attached to the Lambda extension, and then all of your various open source projects that you might be using, or any of your preferred monitoring tools, can directly consume the events from the Lambda extensions API. So this is really the core point that I've been sort of talking about from the beginning, is the fact that because Sumo is directly integrated with an extension, it has the ability to directly integrate with an extensions API. You don't need to do a lot of custom coding in addition, and then sort of directly use the events that are coming from the Lambda function. And similarly, you might also want to dive deep into that capability, which John will talk about a little bit later, and sort of go into the logs API. For example, your standard error or your standard out logs, all of those can automatically be captured in the runtime log, which is streamed to Amazon CloudWatch. That's what really the Lambda Logs API does. The log stream contains all of the logs that are generated by the function code, for example, the standard out, standard error, and the log can be included as a part of the function invocation. It's similar to the Lambda extensions API. What happens is the Lambda extensions can then use the runtime logs API and subscribe to the log streams, which can then directly be embedded within the Lambda execution environment. Once you have the logs, the same logs can be streamed to an extension, and the extension pretty much uses the inbuilt abilities to sort of filter, process, and send those logs to any preferred destination that you like, which is, in our case, would be a Sumo Logic. So if you think about it, it is the extensions that create the interface for you to transfer your logs, your events, logs, metrics, all of those to Sumo Logic. and the extensions can be integrated directly with the logs API. So there are two layers within that, but really this is how we are putting all of these capabilities together. Hopefully this conversation gave you an overview of the basics of Lambda. How do you control a Lambda function? Because there's some natural questions that can happen. Then we talked a little bit about the container support, Lambda layers, and we tied everything back in explaining the execution environment, specifically the extensions API and the logs API, which is what we want to use to be able to understand a Lambda function, how the application is performing, what kind of throttling we can do, can we change the concurrency controls for all of the application to fit together. With that, I would like to sort of thank you for your time and hand it to John for the rest of the webinar presentation. John, I'm going to stop my share.
Thank you, Dilip. Any questions for Dilip before we pick up the Sumo Logic piece? Any questions? Feel free to put them in the chat box or unmute your mic and ask your question while I go ahead and share up my deck. And here we go. So again, Dilip did a great job of explaining Lambda and how AWS, all the intricacies of Lambda with regards to AWS. And so we can use Sumo Logic, or you can use Sumo Logic to look at your AWS environments, your ELB, your Lambda, a whole bunch of other various systems across it. In fact, Sumo Logic, for those of you not familiar, and actually, let me just ask the question in this way. If you would raise your hand, so in the participants area, raise your hand if you are familiar with Sumo Logic, if you're a Sumo Logic customer. All right. Super. So a few of you are familiar with Sumo Logic and that sort of thing. I'll go ahead and clear the hands. Thank you very much. So again, as far as Sumo Logic goes, we're focused, if you knew us years ago, we're pretty much focused on logs and metrics. Well, we've changed that, and now we are focused on observability and security. Observability allows us to see across your AWS environments. It also allows you to see us across your on-prem environments and that sort of thing. So as far as Sumo Logic and AWS, we have a very strong and deep partnership, right? We're advanced technology partner. At reInvent last year, we were awarded the ISV Partner of the Year. So we we have a real strong relationship with AWS, it's some great stuff. AWS has some nice products and services to help you see in their environments. We also have some things that help you see across your AWS environments as well. So they tend to complement each other very, very well. So what I'm going to focus on is I'm going to talk a little bit about the observability piece, how we can see across your AWS environments. And ultimately, we're going to zoom out a little bit and talk about AWS as a whole, and then we'll zoom in and talk specifically about Lambda. So we've got a bunch of tools here that we can use. When you set up, and if you're running AWS, you can either through CloudFormation template or through having a brain cramp here for a second. You can install our AWS application and read information off of your AWS environments, okay? And that gives you some built-in dashboards, gives you some built-in alerts, gives you some built-in things in Sumo Logic that will allow you to see across your AWS environments. And in a few minutes, I'll show you some of this. And more importantly, even after that, we're going to log in. You can log into our training environment, and you and I will do things together. So you'll see firsthand how this all works. Now, as far as observability for AWS Lambda goes, right, we can take our telemetry data from our Lambda logs, as Dilip mentioned, right? We've got CloudWatch metrics and logs, CloudTrail log, all kinds of different sources here that we can use, including the AWS Lambda application. We can also see our AWS observability. We've got something in our product called the Root Cause Explorer, which is going to let us see all the different services and functions that are running across your AWS environments or whatever you want to filter on. And it'll let you see the cause and relationship between those. Because let's face it, AWS environments, like most cloud environments, are very powerful and they're very complicated. And there's lots of moving parts. And so to be able to see in a timeline what's happening here, there, and everywhere is really helpful in troubleshooting and understanding what's going on. So that's what we're going to sort of focus on. And as I said before, as we drag into this, we're really going to go deep into a little focus on maybe the Lambda functions and seeing if we've got a Lambda issue, what the issue is, how we can fix it, that sort of thing. Another aspect of Sumo Logic we're going to talk about here is we're talking about tracing. We can see the various events that happen in a transaction. So if you've got a transaction-based system, we can see across those transactions and see where failures are starting to occur and be able to then, resolve those failures. So we can sit there and see that. And you'll see that here in just a little bit as we get involved in these exercises. So let me just give you a for instance here. We have, like I said, these AWS observability dashboards. And if you don't mind, I'm going to go ahead and stop the slides. I'm going to get into the training environment here, which I have already opened up. I'm already logged in. And so what I can do, what you can do, what we can do is we can approach these problems or this observability one of two ways. One, we can open up the Explore environment. And here in the Explore environment, I can explore by lots of different things. Kubernetes, I can look at real user monitoring to see, like, for example, if you've got a web-based application, how long is it taking for things on that application to load and run? Obviously, our focus today is on AWS observability. So I'm going to select AWS observability. And here are all the AWS environments that I have. As I mentioned with CloudFormation templates, you can easily install, bring your data from your AWS environment into Sumo Logic so that you can have your environment here as well. Now, in our case, per the slide was telling us that we want to look at production, US East 1 over the last 24 hours, and look at our application ELB namespace and see if we got spikes and things like that. So here, when I go into an environment like my prod environment, I open it up and I can see my various regions. So this is automatically done for you when you installed that application. It broke your area down into the various regions where your environments are. And by the way, when I click on this particular dashboard, I can see that I've got more than one dashboard here to see. I could look at my event overview here and I can see, where are my activities coming from? What kind of activities am I seeing? Am I getting any ALB errors? And here I've got some red indicating I've got some problems, gateway errors, all kinds of different things built in. And this dashboard, as I said, is automatically built and set up for you. So all you really need to do once you install the application is you're able to see it and you're able to go. Additionally, in here, and I'll talk about this in a minute, we also can see our AWS accounts events of interest. And so here we can use these golden signals, and I'll talk more about this later, but I can see the relationship of issues. So for example, here, I have an application load balancer error. And right before that, I had an EC2 instance bottleneck. And right before that, I had a DynamoDB bottleneck. And I can even look at the tooltip here and I can see that my issue was a read throttle event. So if you look closely there, you should be able to see that. The point is that this can show me across my AWS environments what services might be causing and affecting other services here. Now, because I am in my prod environment, I'm filtered for prod automatically. If I were to go down here to US East 1, down here in US East 1, I can see all my various services that are running on my AWS environment, including Lambda. And we'll come back and visit that one in just a little bit. But I can, you can, we can go into our application ELB, which is what the slide was asking me to demonstrate. And here in my application ELB, I can sit there and see, again, first of all, I've got a bunch of different dashboards that I can use. I can see that I'm generating some 500 error codes, some 400 error codes in my various nodes. And I can also see that my 5XX is generating a spike, okay? Now I can click on this spike, and when I do, a side panel pops up. And from the side panel, I can then see the information about this spike. I can see some of the information metrics and stuff about it. Under entities, I can then go into, if I want to, and open up another Explorer dashboard, or go into my logs, or go into my metrics, or go into my root cause Explorer to investigate these issues. So the point is, I want you to realize the system is all interconnected. And so I can go from one dashboard to another dashboard to another dashboard to help me troubleshoot. Also, additionally, if I need to filter certain things out, for example, maybe some things are distracting to me, I can then use these controls to filter and select what I want to filter and select on. So that's just designed to give you just a quick little overview into this AWS Observability in the Explorer. Now, back to my slide for just a second. So here, as I said, we can see that we've got this spike, and then we can go in and troubleshoot, investigate this spike. And we're going to do stuff like that in just a little bit. So bear with me. Now, again, what caused that spike? What caused that issue? Well, we can, again, go into our Explorer and look there, or we can also look into our Root Cause Explorer. Now, Root Cause Explorer is another tool that's in the Sumo Logic toolkit. I mentioned earlier that you and I can go in here and look at these events of interest. This gives us a dashboard of the Root Cause Explorer. It's not necessarily the Root Cause Explorer, it just gives us a dashboard of it. I could, if I want to, open this up in my Root Cause Explorer. So that now gives me the ability to sit there and see what I'm filtering on. And if you don't mind, this prod environment is good. This namespace, I'm going to remove that. And my region is good. I like my region here. It's waiting for it to finish loading here. Let me get rid of that namespace. There we go. And so now what I can see is, again, the relationship of my golden signals. Now, if you're not familiar with golden signals, that's a Google thing. And these are the 6 golden signals that tend to help us identify problems and to see what's going on. By the way, in Sumo Logic, if you wanted to, you could go into a navigation panel here, which I've just opened up. And then down here in the navigation panel, if I close this up for just a second. Hang on a second. Here we go. Go into help for a moment. I can go into documentation. Now, I could also type in help.sumologic.com in a URL. And the reason I'm going here is if I search for Root Cause Explorer, okay, here is the documentation that explains to you how Root Cause Explorer can be used, what namespaces it supports, the interface, the 6 golden signals. These are concept 1, concept 2, concept 3. Those are your 6 golden signals. The interface, as far as all the switches, bells, and all that good stuff. So this is the documentation for that. And if you don't mind, I'm going to go ahead and copy it, paste it in the chat box, just in case you want to take a moment and look at it. You can access this from any browser. So again, going to help.sumologic.com will bring up our documentation, and you'll be able to see it. Now, again, I could come from this interface through here to get to the Root Cause Explorer. I could also, if I want to, just for fun, open up a brand new Root Cause Explorer. So under this new blue button, I can click Root Cause Explorer. Let me close this up to save a little screen space. And also let me go ahead and maximize my screen here for a little bit. So what's showing me is it's showing me for the last 3 hours what has occurred. Maybe I like 3 hours. Maybe I want to go longer. I'm going to go back to 24 hours. And so here, as I said, I can see, and it'll take a minute for it to load, I can see all the various golden signals and the relationship and correlation across my AWS environment, which is particularly helpful. Now, what I can also do up here at the top is there's some filters that I can apply. Do I want to see all of my AWS environments, or do I want to focus on a specific AWS environment? Do I want to focus on all my regions or focus on a specific region like US East 1? I can also break it down by my various entities and namespaces. I can also break it down by, various entities here or various metrics. So you can filter what you want to see, and it makes it a little easier perhaps to see what this is trying to show you. And again, here, not only can I filter on my AWS environment. I can also do it for Kubernetes, various applications, all of that fun stuff. Now, what I'm looking at here is I'm looking at these signals, and these signals have a duration, right? The width of these circles is my duration. The height of these circles and the position is known as drift. Drift is how far off percentage-wise am I from a normal value. So we know what your normal values are. It's a AWS environment. So if we see some values here that have drift, we can see that the drift is 4% over a period of 20 minutes. Now, the point of this is that I can see the relationship between, like I said, various services here to be able to investigate and see what's related to what. For example, here I have an error. This error was probably caused by this bottleneck. This bottleneck was caused by that this deployment bottleneck, and so you can see the relationship of all the microservices running across your environment here. Additionally, I can also look at a very high level of all the errors, bottlenecks, and services running here. If I want to, I can focus. Bear with me a minute, it's a little tricky here. I can focus by dragging here. There we go. I can zoom in on a specific range here if I want to. I can also go into a specific error and I can see, I can see information about that error as far as its values, its line, various values associated with it. I can also look at, and again, go into various logs, metrics, dashboards to continue my troubleshooting to see basically what is happening here using my root cause explorer. So all I'm doing right now is I'm just trying to lay down a little foundation so that when you and I go in here and log in and play, we can see what's going on. Any questions so far? Okay. Again, all we're trying to point out is that if you're in the Explorer and you want to go into the root cause explorer, of course you can. And then that root cause explorer provides us full functionality to see, again, a specific entity, a specific event here, and then from that event, I can see information about that event. Like I said, I can see its values. I can go into and go to other dashboards and see basically what's going on. Again, you can filter this. You've got some filters up here that you can play with. So let us play in the Sumo Logic environment. So rather than me yakking, let's do some work. So if you would, fire up Google Chrome or Firefox. Fire up your browser there. And I'd like you to go to the following URL, service.sumologic.com. That's service.sumologic.com. Now that's our training environment. Our training environment's a public environment that you can play with. The only thing you need when you get there is you need two things. You need an email address and you need a password, okay? So let me, first of all, close this up. Let me log out, okay, so that I'm seeing what you're seeing. So if you went to service.sumologic.com, hopefully it took you right here where it's asking you for an email address and a password. Now, what I'd like you to do is I'd like you to pick a 3-digit number. A 3-digit number, any 3-digit number that you want, anywhere from 001 to 999. So if you've always wanted to be James Bond, here's your chance. You can be 007. I'd like you to type your 3-digit number in the chat box, just so we can keep track of what numbers people are using. If there's some duplication, it's okay. If there's a ton of duplication, it's probably gonna be a problem. So thank you, William, for taking 318. Now, why am I asking you to take this number? Phil grabbed 007. Good job, Phil. Why am I asking you to do this? Okay. Well, we're gonna log in as training +sign analyst. And by the way, you can use this today. You can also use this next week if you want to play with that 3-digit number. Now I'm going to grab 985. And you may ask yourself, why is John grabbing 985? Well, 985 was the whole number of the USS Cushing, the last Navy ship I was on in my Navy career. So that's why I grabbed 985. And you want to start add here at sumologic.com. So the email address is going to be training +analyst, that 3-digit number that you select, at sumologic.com. There you go. And then the password is security with a capital S, 22, exclamation mark. Now that password changes every month. So this password changes every month. If you want to come in next month and if you want to play in our training environment and you use these credentials I just gave you and the password's not working, well, you can reach out to me, putting my contact information in the chat box, and I'll gladly provide you the new password. I don't know what the August password is yet. Don't know. We know it when we decide it. But then if you type in this information and you click sign in, it should in fact log you in. So now you and I can do these exercises and play with this environment together. And that's what I'm going to do is I'm going to walk you through some exercises. Any questions so far? If you don't mind, I'm going to go ahead and sign out here. And I'm going to log in with my credentials because I have a lot more credentials here in case you guys get stuck or have a problem. I can fix those things for you. All right. What I'd like you to do is if you're logged in and ready to go, please go ahead and raise your hand. And that way I know that we're ready to go and I don't want to leave anybody behind. So take a moment there, log in. If you're having problems logging in, please let me know. Again, you can unmute your mic, ask your question directly, type in the chat box, whatever we can do to help you. But I don't want to leave anybody behind. Okay, looks like I got about 6 of you logged in. And I realize that many of you are distracted by work and other things, so I'm not expecting 100% participation, but I do want to give you all a chance to play. Okay, David says his account is locked. Please try again in 14 minutes. Good. Do me a favor, David, try a different number. Try a different 3-digit number, please. Okay, rather than waiting 14 minutes. So pick a different number. You can have 985 if you want, David. That's fine. Like I said, I'm going to give it a minute here to get you guys all logged in, and then we're going to go ahead and play. David, are you able to get in? By the way, one thing, if you try to type in the password and email combination incorrectly, good job. Incorrectly more than 3 times, it will lock the account out, and then it will unlock it after 15 minutes. That's why we've got this training environment set up. Okay. So for those of you who want to be in, I'm assuming everybody who wants to be in is in now. I'm going to go and lower the hands. Okay. Let's take a look at this. Let's go into the slides here real quick and let's talk about our lab activity. Okay. So we want to focus on Lambda logs and observability. Probably makes a lot of sense as we were talking about Lambda earlier, right? So what we want to do is we can get alerts here on issues. We can also create those alerts. We can also do a lot of different things. But what I'm going to do is show you where the alerts come from, where we can see them, stuff like that. And then, like I said, we're going to go ahead and walk around here. So as far as my alerts go, in Sumo Logic, if you click on this tab with the bell, that's all of your alerts. And if you want to, of course, you can sort your alerts by name or by ID or by severity or whatever you want. And so I can scroll down. I see a lot of these alerts have been resolved. That's great. Okay. But I can, even if it's been resolved, I can go into any one of these alerts, click on it, and I can see, here's a depiction here of what the issue is. I can see what metrics or logs triggered this alert. I can see any related alerts that happened along the same time as this. Maybe they're related, maybe they're not. Down here, I can sit there and see my various metrics and their various values. And then also I might have some context down here. This one doesn't have any context, but I can basically see that. All right, thanks, Dylan. So I can see that. I can also look at my monitor history here to see if this has occurred before, right? This alert occurred this before. The other thing we've got is we've got the ability to create a playbook, right? And the playbook is really kind of cool because the playbook says, okay, if you have this alert, here's the recipe on how to troubleshoot it. So I could click on the playbook. I know there's not a playbook here, but I could click on the playbook and it would tell me, okay, go here, check this, go here, check this, go here, check this. And so you've got some sort of a playbook on how to resolve things, right? So there are alerts, and I'm just going to close that alert tab up because we're, the alerts get generated. They can be notified. They can notify you via PagerDuty, write a Jira ticket, send an email, all kinds of different ways we can communicate that. Send it through Slack or Teams, all kinds of different ways we can communicate that alert so that you're aware, hey, we got a problem, okay? Now, when you install the AWS app, it also installs a bunch of alerts for you, and you can customize who you want those alerts to go to and all that fun stuff. But another approach we can take on this, assuming we didn't get an alert, or maybe we want to do something a little different here, is we can check it out through our observability. So what we're going to do is we're going to go into Explore. So again, you can click on this Explore tab button here, or you can go to New and click Explore. Now, as I mentioned, our focus is on prod, right? We don't care about dev stage. So let's click on prod, and then we're focused on US East 1. So here on US East 1, I want to look at Lambda. So if I scroll down here, I'll see there's a whole bunch of AWS Lambdas. And when I click on these, you'll notice that my dashboard changes, right? As I go through the various namespaces or various regions or whatever, my namespace change to help me see what's going on. Now, again, here, and when I'm looking at my Lambda, I can see where my Lambda functions are being called from. I can see the various invocations and patterns compared to this week or last week or whatever. The duration, I can see throttling if I want to. I can see the users that are using the Lambda function services. No offense, this is pretty powerful. You can see right across who's using your Lambda environment and what's going on, okay? Particularly powerful, I think. Now, as I scroll down here, I can see my top functions by duration. So I can see, which functions are taking a bit of time here. I can see my top functions by memory used. So I've got a good idea. Maybe if something's taking a lot of memory, maybe I want to talk to that development team and see if they can clean it up. But over here to the right, I have successes and failures. And it's interesting when I look down here at my successes and failures, if you look closely at your legend here, and if I turn off my successors by clicking on it, or I'm sorry, select my failures only, I can see that this get billing information is failing quite extensively. Okay. In fact, let me do this again. There we go. It's never succeeded. It's always failed. So I've got a function that's not working. And it may have created an alert, created problems, things like that. So what I want to do is I want to filter this dashboard on this function. I'm not sure if you can see it real clearly. Let me go ahead and try to magnify my screen here a little bit. Try to make it a little easier for you to see. Okay, but this function is called get billing information. So what I want to do is I want to filter this dashboard for that function. So up here at the top, I can say function is get underscore, and hopefully here in a minute, it'll give me the IntelliSense that says, okay, here's get billing information, or I can start just typing it in. And I can hit the return key on my keyboard. Let me shrink myself back down here a little bit. Come on. Okay. What did I not type right? Let's try this again. Get. There we go. Get billing info. There we go. That should work. Refresh this. There we go. So here I am again looking at my Lambda overview dashboard. And of course, there's other dashboards I could be looking at, but this is good. And as I scroll down here, or scroll back up actually, I can now see here are my successes and failures. I'm focused on only this function. And I can see this function's failed 719 times in the last 24 hours. But more importantly, I can see the frequent operations here. And so I said it failed 719 times. Well, it failed 248 times in the evoke and failed 135 times in the list function. I want to know what's causing this. So what I can do is I can see this dashboard here. These dashboards are made up from underlying queries, either metric queries or log queries. But what I want to do is I'm going to take this most frequent function operator, and I'm going to go ahead and click on these 3 vertical dots, and I'm going to open this up in a log search. And when I click on that, here is the query that it's running in the background. Here's the query that it ran again for the 24 hours. And then here is my aggregates, which show me, again, a count, a summation of all the time somebody used invoke, somebody used list function, somebody used update function control or code. Now, my question to you is, if this thing broke and it's not working, it's probably not somebody who tried to invoke it. It's probably not somebody who did list function. It's probably somebody who modified the function code. So what I want to do is I want to filter for this update function code. This field is called event name. So I can go back to my messages tab, which show me my raw messages here. And in my raw messages, I have something here called the field browser. And in the field browser, I see there is a field there called event name. And when I click on it, I see my various event field names, and I can click on a specific value in here, and it's going to add that line of code to my query. So now it's filtering and only showing me any messages associated with this update function code. And so here I can get a sense for what caused this. Now, bear with me a second, folks, because this is not playing the way I want it to. Bear with me. Just let me go back here. 24 hours. Let's go back the last 3 days. Just humor me. There we go. There's what I wanted. I wanted update function configuration, not code. Update function configuration. Apologies. All I did was I went back to the previous query, and I went again from here to my query. I opened it up for a little bit more time frame. I changed it to 3 days. Now I'm going to go back to my messages. I'm going to go back here to my event name again. This time I want to grab the update function configuration. There we go. That's the one I wanted. Now, in the case of this update function configuration, somebody's updated the configuration. Who did this? Mark Smith did this. So now I can ask Mark, what did you do? Oh, I changed a username, or I changed a password. Well, no wonder our function isn't working, right? So now I can focus on what Mark did and understand what happened, and we can get Mark to resolve this so we get rid of all those errors. So this is just a simple example of how we can use Sumo Logic to troubleshoot and investigate issues that are happening with our Lambda functions or anywhere in our AWS environment. Any questions so far? Okay. We just check something real quick here. Okay. Make sure everybody's got their mic enabled. And Trevor, just so you know, I'm trying to enable your mic and it's not working for some reason. I'm not sure why, but all right. So that takes care of that. Okay. Phil says the training environment is a little different. A little different. I assume you're asking it's a little different from your environment. I think that's what you're trying to say. Right, Phil? Not seeing the same dashboards as me. Okay, hang on a second. Let me go back here and stop the slides. Just bear with me a second. Let's go back to training environment. Make sure I am, in fact, in the training environment. I am. Good. Okay. So you should have been able to, in our training environment, grab yourself a new Explorer tab, either from this button or this button. I don't really care. Explore. You should have been able to go into prod, US East 1, AWS Lambda. And if you don't mind, I'm going to squish this over here to the left. Okay. You're not seeing prod. That's interesting. Anybody else not seen prod? Oh, yeah, I'm sorry. Good catch. Change your explore by. Change your explore by to AWS Observability. Thank you. Good catch. Thank you. That was from Dan. So thank you, Dan. Good catch. So you want to make sure that you're selecting AWS Observability here. Then you should be able to click prod, US East 1, AWS Lambda. Okay. So Phil, I appreciate you asking the questions, because what's happened to you, it maybe happened to somebody else. So I absolutely appreciate that. Now, again, here in AWS Lambda, as we saw, and don't worry, we got plenty of time here, guys. We saw that we got a bunch of errors, right? We scroll down this dashboard here a little bit, and we see that this function's never worked, right? At least in the last 24 hours. And we want to know why. Now, I could theoretically click into a log search from here, but I don't know if this query has all the information I need. I do know that this query has all the information I need, but what I want to do is I want to filter this to only see this function, get billing info. So I'm going to go back to the top of this dashboard, and up here you can see when I clicked on prod and I clicked on US East 1, it automatically filters that information. I want to filter for that specific function name, get, and if I type in get, I see there's get billing information. And now this will update all my dashboards here. I'm not sure why it's throwing that error. And then down here, so I can see that I've got 720 errors here associated with this. It's focused and showing me the data for only this function. Now, the problem I have is that I know because I'm very familiar with this function and done this exercise lots of times, that I'm missing something here. I'm missing an event name. Because again, if a user invokes it, that's not going to cause it to break. If a user does list functions, that's not going to cause it to break. If a user does update function code, that could cause it to break. But also if they modify the configuration, it will cause it to break. And so I'm not seeing the update function configuration. If I go back here and if I change this to the last 3 days, it's going to rerun this query for the last 3 days. Now I see this function. Now I can go into my log search by clicking these 3 vertical dots, go into my log search. And again, it's basically, this is the query that I'm seeing the results of. Here's my results. Here's the query that makes it up. The best thing about this is I don't have to worry about writing this query. The query was already built for me. Now I want to focus on only the messages that deal with this update configuration. The way I can do that is I can go to my messages tab, which show me my individual messages. It also shows me something called the field browser. And here in the field browser, if I scroll down and look for event type, and if I click on the word event type, I can see here my 4 event types. I can click on this last one, the update function configuration. And when I do that, that adds a where clause to this. And that's then going to filter and only show me these event names. And then I can look at the log message for this, and I can see that Mark Smith is the one who changed this configuration. And I can ask Mark, what did you change? Because this function isn't working. You broke it. Okay. So Mike asked a really good question. Is the field browser populated based off the parser? It is typically based off of something called field extraction rules, or if they're or they can be based on the parser. So there's lots of ways to get fields in here. If we parse out those fields, they're automatically added here. So Mike, you're absolutely correct. We also use field extraction rules, they're automatically here. Also, if we come across the logs are in JSON, our product automatically extracts all the JSON fields and makes them available. So Mike, I hope that answers your question, sir. And by the way, obviously when I'm alluding to about how field parsers and stuff work and all that, we've obviously got lots of training to help you out with that. And by the way, all of our training is free. So, you know, there's no excuse if you want to learn more. We've got lots of opportunity to help you here. Okay. So hopefully we're now good with that exercise. We can see how we can use Sumo Logic to troubleshoot an issue. Okay. And as we can see here, we looked at we filtered for our get billing information. We then found the culprit here about Mark Smith, and we're able to see that Mark changed something and, talk to Mark and all that fun stuff. So, right, what did Mark change? Why did he do it? That sort of thing. And see if we can get it changed back. All right. Another aspect to Sumo Logic and our relationship with AWS and Lambda is we can also use traces. We can trace Lambda functions within our microservices. So let's face it, right? You've got AWS environments, right? Those AWS environments are running a whole slew of microservices. Some of those microservices are probably created through Lambda. Regardless whether they're created through Lambda or not, you can, I can, we can see across those microservices and see the transactions and see where things are falling off. So tracing is one of the 3 pillars of our observability. I mentioned to you guys a while ago, years ago, Sumo Logic was viewed as a logs and metrics company. Well, so we changed that and we now focus on observability. And the 3 pillars of observability are still logs, which tell us why things broke, metrics, which typically tell us how they broke, and then traces allow us to see the transactional breakdowns that occur during a transaction. And so you'll find that to be very, very handy for us, okay? And so we take advantage of this tracing capability. Again, these are nice, but we were missing something in our deck, and that tracing capability was what we needed to have. Okay. So that's what we added to it. And like I said, we changed our focus. Tracing is critical when you and I order something, when you and I go online, when you and I go to a website. Tracing is very critical to understand, where is the user going, particularly in an AWS environment. You got a bunch of different systems, a bunch of different microservices, and if you got Kubernetes in here with the different nodes and everything, it can be kind of interesting. So a particular user's path may break somewhere in that path, but the other nodes are running fine and everything works. So identifying these, troubleshooting these are kind of interesting. And the good news is I think you're going to find our tracing products going to help you out there a little bit. So we need transactional tracing to be able to locate our failures, improve our performance, and take care of things. Before I get into the transaction tracing, there's something else I want to show you, okay? We had this fictitious company called Sumo Logic Coffee. And Sumo Logic Coffee provides a great, great cup of coffee. In fact, recently we've also set up so that you can order some wonderful pastries. And so what happens is you can go to a kiosk or you can order through the app online, and you can sit there and pick out what you want and then go to the store and pick it up, right? Piece of cake. I know that was a pun, by the way, unintended pun. But the point is, and it's just to show you something else here. How long does it take those web pages to render on that kiosk? Well, there is something in here in our Explorer that we have called the real user monitoring. I'm going to segue out for a second here. So here in my real user monitoring, I can see my coffee bar app, and I can see how long things are taking from the end user's perspective, how long things are taking to load, how many requests we're getting, the different browsers we're seeing, the different operating systems we're seeing, the different geographic locations. And then I can see my website performance here. So I can see from the time it starts to load to the time it takes to load. That's pretty significant there, right? We've got, looks like about 20 seconds. That's not good. And so we can see some of the performances. So real user monitoring is another aspect, another tool that we have in our arsenal that lets you and I see across these applications, particularly web-based applications, to see how they're performing from the customer's perspective. What is your customer seeing? So just wanted to mention that to you. It's not necessarily part of the presentation, but I thought it's valuable. Now, back to our issue, what we want to do is, again, somebody's making a transaction, they're making a purchase, they're selecting things, they're paying for things, maybe they're canceling the order, whatever they're doing. We need to be able to see across the various transactions of what's happening here. So what we're going to do is we can go into our service map. I'm going to do this a little differently in the slides. So if you would follow along with me, and by the way, if you've got tabs open up here, you can close all of the tabs that are open by simply clicking on the 3 vertical dots on any one tab, and there's an option that says close all tabs. That'll make it easy for you. Now, one of the easiest ways when you're looking at an application to see what's going on is if I click on this new blue button, you'll see I've got something here called the service map. And if I click on this service map, I can see the various applications I have and the various connections of those applications. So here I am looking at various applications that are running, microservices and stuff that are running. And if it's in red, that means I've got abnormalities. The size of the circle is the number of requests per second. And so obviously this is a training environment, so I get lots of things that are not working really well. Okay, it's designed into that in mind. Additionally, up here, I can filter by application. So I can filter by, say, the coffee bar app. If I want to, I can filter by my environment, my service name. I can look at, again, Lambda or whatever. But the point is, I can see the relationship. So great. Somebody goes to the coffee bar and they say, hey, I want a coffee, right? Well, that's going to go to the coffee machine, the barista. The barista is going to fire up the machine. It's going to make sure we got grains and beans and stuff. We're going to grind those puppies up. We're also going to dispense some water. And then we're going to give that coffee back to the user. The user then is going to go to the cash desk. The cash desk is going to approve or deny the transaction, and off to the races we go. So here I can see all the interconnectivity between the various services. Now, obviously in the real world, we hope that you don't have all these red circles, okay? But to show you how this works, I'm going to go in here where it says water service. And I'm going to click on water service, and I'd like you to do the same. So click on water service, click on the same. And here I can sit there and see my water service. I can see its latency, which isn't too bad. My request per seconds, my errors, again, not too bad. But if I want to, I can open this up in either an entity dashboard, my traces, my spans, metrics, whatever. We're going to go into traces. So if you click on traces, this is now going to show us the coffee bar app, specifically the water service. And so here are my individual transactions, okay? We've got spans and we've got traces. A trace is when a customer makes a request. All of the spans are the individual steps that occur within that trace. So I've got different traces. I've ordered coffee. You may have ordered a pastry. Somebody else may have ordered something else. These are all the individual transactions. Within these transactions, I have different steps that have occurred. Now, what I want to do, just to make it a little easier for myself, is I can sort this by the number of errors in descending order. So I'm looking for a high number of errors and a fairly high degree of latency, okay? So I've got this one here that has about 823 milliseconds, and hopefully you're seeing something like that as well. And I can go in here and I can click on this. And now it shows me the transactions. This is my trace, my whole transaction. And in here I have spans. The user made a click, right? And then I'm going to do a post and send that information back. And so what I can see is all the different processes here. Now, first thing, color. The color represents the microservice. So all this dark blue, purple, whatever color you want to call this, is all part of my click on my HTTP post. Here's my Lambda functions. And right now here, my Lambda functions are actually behaving just fine. They're down here in brown. Here I've got other functions here as well in light blue. And I've got other functions that made this up, and I can see how long it took, okay? So for example, here, I can see how long things took. Now, what I want to do, notice I got a bunch of red lines. These red lines indicate where I had problems. And if I want to, I can throw the switch up here that says error spans only. And it kind of grays out all the things that don't have errors, making it easy for me to focus on where the errors are. Now, what I want to do is I want to go down these errors and I want to focus on this right here where it's getting the coffee from the coffee machine. This one right here. And if I click on this, again, a little side panel comes out, And it proceeds to tell me about the operation. Get coffee, it's on a server, start time, end time, post. There was a 503 error. I don't know what a 503 means yet, but we'll figure that out. Over here in metadata, I can see all the metadata associated with this. Came from a Python request. I can see Kubernetes, Sumo Logic, all the different metadata tags. Here in my entities, again, I could bounce to other parts of this if I want to. I don't need to, but again, I can go up and look at the bigger systems if I need to. Now, back to summary, back to this get coffee summary. I can open my logs and look at the span ID, or I can open the logs and look at my trace ID. Remember, my trace ID is the entire transaction. The span ID is what happened for this specific microservice. So I want to choose the first one, the span ID. I'm going to click on that. This is now going to open up my logs for that particular event of getting the water. And my latest message is on top. My earlier messages are below that. So originally here it was preparing to espresso coffee, right? Here's the trace ID, that sort of thing. And so here what happens is I'm missing some ingredients, okay? Normally it might say something like missing the beans or missing the water or missing the whatever. So the point is when you create this tracing, this transactional tracing, you can specify what you want these messages to say, and you can probably provide more information like missing water or missing 8 ounces of water or missing, 23 grams of beans or whatever you want. But now I know that 503 is a result of I'm missing some ingredients here. And so I can see, what's going on, fix it, that sort of thing. Now, again, hopefully this is kind of a relatable exercise because, you can relate probably to buying coffee. I know I certainly can. But think about it. You've got users who are trying to log in and they're failing. You can see the transaction process that occurs. If you've got users trying to purchase things and they're having issues, you can see the transaction process, not necessarily the credit card information. You can filter all that out, so we're not seeing anything sensitive, but you can see the transaction process. You've got a patient trying to get scheduled for surgery or something like that. Again, you can see where things are in that process. Any questions about this? Hopefully you're because no offense, cloud systems are very complicated. There's a lot to them, a lot of power, a lot of functionality. Being able to see across those cloud systems, in my mind, is a wonderful, wonderful thing to see the relationship between the microservices, to see the transactions and that sort of thing. So back to my slides here for a second. So again, we can see these spans here, and we can see the Lambda activity of getting coffee or whatever. Those work just fine. It's the other aspects that may not have worked. You'll notice this one doesn't have a switch to throw from errors because this one doesn't have any errors. Everything worked fine. So again, 41% was my coffee bar, 28% here was my cache desk. My Lambda function was this much time. And so I can see where things broke down. And in this case, everything worked great. So you can use tracing if you want to see, again, the various transactions that happen, and the service map typically helps you with that. Then you can go into the span analytics and see the various spans, the various transactions, traces that are occurring, right? And then you can break and investigate a specific trace down and see the individual elements that make that up. All right. Any questions? Because the good news is I'm going to wrap this up and we'll get you out of here a little bit early. Any particular questions? Okay. Dan asked a really good question. How does trace IDs get perpetuated through different service calls? Does each service need to manually pass it to the next service? What happens is that you're going to set up in your applications the various trait that you're going to mark them for tracing. And the system generates the trace IDs and manages all that for you. But the point is, you're going to say in my application here, I want to be able to put a trace here, trace there, and so forth, so on. Dan, specifically, we teach you how to do that in our observability administration class. That's where we show you how to set up these trace IDs and how to set up transactions. So I hope that answers your question. Good question. Thank you. And we also show you we go in more detail on this on our observability fundamentals class too, but as far as how to set it up, which is usually what people are really interested in. That's that we do in the admin class. Thanks for the question. Any other questions, ladies and gentlemen? All right, let's wrap this up. Hang on a second. I see a couple of folks have do not have the ability to talk. Let me make sure in case you get questions, you can do that. I've enabled everybody's ability to talk. So let's do this. Okay. So if you want, like I said, where we teach you how to set this stuff up, we have a observability admin class that you can sign up for and take. It's free, right? As far as that's where we show you how to set these tracing points and that sort of thing. The other thing is, hopefully you're aware of, you received in an email, the invite to this, that we are offering a 500 AWS credits. Now, the trick in order to get those 500 AWS credits is you have to begin a free Sumo Logic trial. And once you ingest some data in there, about 1 gigabytes of data, then you're eligible for those credits. Now, for those of you who cannot scan this code, hopefully you can. But if you cannot, I'm going to go to this URL. I'm going to take this URL, which is the same thing that the scan provides you, and I'm going to paste it in the chat box. So that's where you go to sign up for that free trial. And so if you, like I said, do sign up for a free trial, you put some data in there, you will be able to get yourself 500 AWS credits. It's really kind of cool. Questions about that? All right. Last of all, if you want to know more about our observability solution, right, you can go to our documentation, again, help.sumologic.com. And if you search for observability solution, you can see information about that. Again, we also have training, although I have to be fair here. Right now, we're on a bit of a hold as far as our training. If your company needs some training, some Sumo Logic training, we'll gladly do that between now and September. But we are holding off on training for our Illuminate event. So Illuminate is September 13th and 14th. And there's our big conference. It will be done virtually. We'll be offering all of our classes so that you guys can sign up, and it's free. And we'd love to see you at our Illuminate event. Love to help you with some classes and some courses. In the process of building it up right now, so stay tuned. You'll hear more about it. But again, if there's anything else I can do to help you, or anything else Dilip can do to help you, please don't hesitate to reach us out. Reach out to us. You've got my contact information in the chat box. Dilip, if you want to put yours in there as well, you can. Otherwise, on behalf of myself and Dilip, I want to thank you all for spending the last hour and a half with us. If you have any questions or you want to play, feel free to stick around. If you want to go, feel free to do that. But thanks a lot for your time and your effort. We look forward to seeing you again soon. Thanks, folks. Have a wonderful day.